days, put on your protective eyewear and plastic gloves. Clean out your HNMR tube using this apparatus by the back sink. First, you set this in this center arm with the cap on the bottom so you don't lose it forever. Turn on the right hand sink to start the vacuum and squirt acetone into this side arm just a few times to get it cleaned out. If you want to use it right away, take off the plastic cap and put it in the oven until it's dry. Using an electronic balance, measure out a sample of 10 to 25 milligrams. In a dry and clean vial, dissolve the sample in 600 to 700 microliters of deuterated chloroform. Transfer your sample through a cotton filter into the clean and dry NMR tube. Approach the HNMR machine with fear and respect and open the lid. Clean your HNMR tube with a Kim wipe. Remove the NMR tube that was in the machine by pushing the round button on the front left side of the lid. Transfer the white spinner to your NMR tube and establish that it is at the right height using the guide on the front of the machine. Place your NMR tube in the NMR machine in a careful manner so that the white plastic spinner will not be moved. Flip the lever to the horizontal position to start the NMR tube spinning. The PNMR program. When the blue screen appears, type NS space 8 and hit enter. Then type ZG and hit enter. This window pops up and just hit save. This is how the screen looks while it's scanning. Wait until all 8 scans are prepared by the machine. When all the scans have been completed, hit Control F1. So minimize this and open the NUTS program, and then hit OK and Control F2. And then open your PNMR. You can name your file in the comment section. Enter ZO. Choose a strong signal on the left and click and drag the mouse over it. When the signal is highlighted, press 1. Then choose the signal on the right, also highlight it, and press 2. Then click enter. Type in PE. The view of the spectrum will change, and you can separately use your left and right mouse buttons to drag up and down and adjust the graph, your view of the spectrum. Adjust it until the baseline is level on either side. When it is level, press enter. Choose the signal on the right of the spectra that corresponds to the TMS peak, and while holding the mouse down, click the letter V and in the offset information field type 0. Type FB. Make sure none of the bases of the peaks are highlighted in pink, and if so, undo that. If flat areas are not highlighted in pink, do highlight them. When you're done, press the letter L and hit enter. Type ID. In order to assign values to the integrals of the peak, position the cursor on the left of the chosen peak, double-click, and then position it on the right side of the peak and click once. Do this for each peak. You don't have to integrate the TMS peak. Choose the peak that you recognize the best. Hold down the mouse button and press V. Then assign the number of hydrogens you think that peak has. Hit enter 2 times. Then type DP and click on each peak you would like to label. Go to the View section in the menu of the program and select Show Integrals and Show Peak Labels. Insert your flash drive into the computer. In the File menu, save your file to your flash drive. Then, in the Edit menu, copy the bitmap to clipboard. Open the Paint program and edit, paste your spectrum into Paint. Save this file on your pen drive as a JPEG or TIFF file. Remove your sample from the NMR machine and replace it with one of the samples from the rack. HNMR stands for Proton Nuclear Magnetic Resonance, and it is a spectroscopy method used to deduce the molecular structure of the compound. It's a very powerful tool for organic chemists, biochemists, and in industrial settings. Molecules absorb electromagnetic radiation, which is measured through spectroscopy. The NMR spectroscopy uses low-energy radiation to scan the samples, resulting in formation of a spectrum, a graph of absorptions corresponding to particular energies. In the theory of NMR, the nuclei of a hydrogen is depicted as a magnet, which aligns against or with the magnetic field that it is inserted in. Therefore, protons in the organic compounds can be identified by their peaks at certain chemical shifts in the NMR spectrum. In the NMR machine, a magnetic field is produced, which makes the nuclei of the protons present in that sample aligned to the field. They absorb radio frequencies in multiple ways depending on the types of the electrons around them, which is detected by the NMR machine and enables the compound to be identified.